What's up guys, welcome back to the channel. Today on this video we'll be doing exponential indefinite integrals. We're gonna do the application as well, and also on which formulas or which function are we gonna apply this rule. Now before we start though, I would like to say, if you are watching a video from the first time on this channel, I'd like to say welcome to the channel guys, and I would advise you to subscribe to the channel because I've made previous lots and lots of videos on previous question papers and also videos on other chapters. So I'm still going to make more videos on previous question papers and more videos on other chapters, so you don't want those new videos to miss you guys. So subscribe to the channel and don't forget to hit the bell notification. Now that we are done with that, let's just start here. So the exponential indefinite integrals, before we start doing them, how about we do a revision on differentiation, the counterpart of integration. So let's do a revision on differentiation of exponents. So the function for exponent usually looks like this. The exponential function like this. Let's say we have 3 to the power of x plus 2. Say we have a function like this. So the first term here, or the first term here, it's a function. It's an exponential function, and the second term is just a normal function. Now if we have this, and then they say find the derivative of this function here. So dy over dx is gonna give us, start with the first term. Now if you still remember from our derivative, it's gonna be 3 to the power of x multiplied by natural log, then our base is gonna be 3, right? Then the second term here is gonna be 0. So remember, when we find the integral or when we differentiate, the constant is gonna be 0. Alright guys, if it so happen that you don't remember, or if you want to do revision on your differentiation, go to this video and watch the exponential differentiations. Okay, now that we manage to do our differentiation, now it's time for us to do the integral of the exponents. So before we do that, you need to understand, when you integrate, it's when you move from this side here going back to the original. It's when we move from the derivative to the original. Now there is a formula that we use guys when we find the integral of the exponent function or exponential function. So let me show you the formula before we apply it. So the formula, it goes like this. So we have a, which is our base, to the power of n, which is the coefficient of x. So the power of n multiplied by x dx. Remember, dx basically means that we are integrating in respect to x. Right, so the integral of this type of a function is going to be as follows. It's going to be a to the power of n x. Remember, a is our base, and then it's going to be divided by n, the coefficient of x, divided by natural log a, plus c. Right, do not forget, c stands for the constant, and also c indicates that we are doing indefinite integrals. So do not forget that one, guys. Right, so this is the formula that you're going to use whenever you have an exponential function you have to integrate. So let's do this one. Remember, let's take it from our derivative to the original. Remember guys, integration is when you are going back from differentiation to the original. All right, so obviously it's going to be given to us like this. So you're going to have 3 to the power of x multiplied by natural log 3 dx, right? Okay, let's just stop here. This is the same as that. You guys see? So it's time for us to take it back there. Now let's do it. So what would be the integral of this? Supposed to be something like this. Supposed to be something like this. Not exactly, but something like this. So we have y time for us to apply this formula here. So in this case, our a is what? Our a is the base, which is 3. I'm gonna use this one here, which is 3. So it's gonna be 3 to the power of n. So our n here is the coefficient of x, so it's not written, so it's gonna be 1. So multiply by x. So we divide them. And what is our n? Remember, it's the coefficient of x, which is 1. Even if you don't write it, it's fine. Multiply by natural log, then our base, which is 3. So we have 3 there. Multiply. Remember, natural log 3, this is a number. And remember, when a number multiply the base, it becomes a coefficient. So this is a coefficient of the function, the coefficient of the base here. So you write it as it is, guys. Okay, you write it as it is, and then do not forget plus c. Remember, now let's come to plus c. The c represents the constant, guys. We cannot know the exact value of this constant. Remember, this c represents that constant, so we cannot know the exact value. So instead of writing 2, rather write c, because you really can't know for sure. For example, if this was 3, still we're going to get the very same answer here. So you see, you cannot just guess and say 3. So the best way is to write c. Okay, right, I hope you understood. So if you continue here, we say natural log 3 divided by natural log 3, you're left with 3 to the power of x plus c. So this, guys, it's a standard exponential indefinite integrals, right? As you can see, I told you that it's going to look similar to the original. We have 3 to the power of x plus c, 3 to the power of x plus 2. Remember the constant, I repeat, you cannot really know the exact value, right? It's impossible. All right, or maybe it's possible. Maybe we haven't reached that point yet. All right, so now that we have done this one, how about when we do the one with the base as e, right? We just erase this because we need the space here. Okay, let's erase here. We need the space here, guys. All right. What about when the base is e? Remember, the base here was a or 3, right? So when the base is in, for example, let's say they want you to find the integral of the following function. Let's say we have e to the power of x, then dx. Again, if you still remember, when we differentiate a function like this, it's gonna give us exactly that. It's gonna give you e to the power of x. So let's see if we take it back now. If we integrate e to the power of x, are we gonna get e to the power of x? Right. So we still gonna use this formula here in order for us to get our answer. So y, in this case now, a is e, so we are fine. And then the x exponential coefficient is going to be 1, so it's going to be x. It's going to be x there, and then divided by, now n again is 1. It's 1, so we have natural log, then the base is what? In this case, is going to be e plus c. Now, before we continue, there is some information that I need to remind you guys. If you still remember, natural log e, this is equaling to 1. If you can go back to your natural log studies or logs, you will see this is equaling to 1. So basically, this means that our final answer is going to be e to the power of x plus c. Remember, c is a constant, guys, right? But if you can look at this, this is e to the power of x and e to the power of x. So c means constant and also indicates that we are doing indefinite integrals. Guys, this is how you do this one here. So this is the formula that we use, guys. Do not forget, you can use it whenever the base is e or whenever the base is 3 and or a or whatever, guys, okay, as long as you understand how to use it. All right, people, I hope this video managed to help you understand. If you didn't understand, you can watch the video and rewatch again, or leave a comment on the comment section. But if this video did manage to help you, you can like the video, and do not forget to subscribe to the channel. Hit the notification bell so that whenever I upload the video, you can able to see the new video. But at the end of this video though, there will be a playlist of this exponential indefinite integrals where I will be having a lot of videos applying this formula here. So if it's so happen that you don't understand, maybe those videos will help you understand. So click on that playlist that appears there on the video and watch those videos in sequence order. Thank you very much guys. Until next time, cheers.